Welcome everyone. Today we are going to tackle one of the most misunderstood statistical concepts, the standard mean, the standard error of the mean, or shortly we can pronounce it as SEM. So if you have ever opened a scientific paper, or if you have seen a scientific paper, you may have seen mean plus minus SEM, right? Usually it's written as mean and then plus minus and there is a SEM, right? And you wonder what it actually means. So I think you're not alone. Myself also, when I see for the first time this SEM, I wondered like what exactly is that, right? So many students and even researchers, they mistakenly believe SEM measures how actually spread out the data are, but actually does not measure the spread out of the data. And by the end of this video, I believe that you will know exactly what SEM tells you, why it exists, and how to interpret it correctly. So before we define SEM, let's start with a simple story. Now, there's a pizza analogy. Imagine a factory producing 10,000 pizzas every day, and suppose your job is to estimate the average weight of every pizza. So I have a question. Would you weigh all 10,000? Of course not, right? Because it's difficult to weigh 10,000 pizzas, right? Of course, it's not impossible, but it's difficult, right? So you randomly choose 5 pizzas, weigh them, and calculate the average. So the important question is not just what is the average, but how much can I trust this average? And that question is exactly what the SEM answers. So to understand why, we first need to understand the difference between a population and a sample. Now, the population is like we're going to carry with this pizza analogy. So the population is every pizza produced by the factory, which is 10,000, right? And the sample is only the 5 pizzas you measure, because we almost never measure the whole population most of the time, and science relies on samples. So every new random sample gives a slightly different average. So the sample mean is an estimate. That means it's an estimate, so it's not an absolute truth. Now imagine repeating this sampling process again and again. So suppose we repeat the experiment 1,000 times, and each time we randomly pick 5 different pizzas and calculate a new average. Some averages are slightly higher and some are slightly lower. So if we plot all those averages, we get what's called the sampling distribution. So the SEM describes the spread of these sample means. And you need to notice that it's not describing the spread of the individual pizzas. So this is exactly where people confuse SEM with standard deviation. Now, standard deviation, or short form SD, it measures the variability among individual observation. Think of students in a classroom. Some are taller, some are shorter, and so what's going to happen? So if some are taller and some are shorter, then the SD measures those differences. The SEM asks a different question, and it asks like, if we repeated the experiment, how much would the average change? So what SD actually telling us is SD is about individuals, and SEM is about the confidence in the average. So once you understand this difference, this formula becomes very intuitive. Now, the SEM equals the standard deviation divided by the square root of the sample size. If you see here, this is the basic formula. And I think I don't recommend memorizing the equation. Instead, focus on what it means. What it means exactly is larger variability increases the SEM, while collecting more observations, it decreases the SEM. because our estimate becomes more stable. Now, most of the time when we try to measure the standard deviation, we use Excel. So you can take a screenshot from this image, and you can try to use this formula if you are using Excel to analyze your data. And most of the time nowadays what happen is we are using those softwares where we don't need to put the formula. But anyway, if you need the formula, you can use the formula that is mentioned in the slide. Now let's see with this concept with real numbers. So both data sets, if you see here, have the same mean of 100, but data set A has values tightly clustered together, if you see closely, whereas the data set B is widely scattered. So if you see here, the data, this is the data set A and this is the data set B. So even though the averages are identical, but we are much more confident in the data set A estimate because the values are closely together. Now let's apply this concept to a real biological experiment. So imagine we are measuring the preference index for the fruit flies, and the wild type experiment produced almost identical averages, giving us a smaller SEM. Then the mutant experiments vary much more from the replicate to replicate, producing a larger SEM. So what exactly this tells us is that the wild type mean is estimated more precisely, and this naturally brings us to the error bars. Now, when you see mean plus minus SEM on a graph, remember that the error bars do not represent how different individual animals are or individuals are. Instead, they show how precisely the mean has been estimated. Small error bars indicate the repeated experiment give similar averages. Large error bars indicate more uncertainty in the estimate. So how can we improve that precision? So increasing the sample size is one of the easiest way to reduce the SEM. Measuring only 4 individuals gives an average that can fluctuate a lot, but measuring 100 individuals produces a much more stable average. That's why the SEM decreases as sample size increases. Now, reviewers actually frequently ask authors to report sample size, clarify whether error bars represent SD or SEM, and sometimes even show every individual data point. These requests help readers judge how reliable the reported mean really is. Now, let's quickly check what you have learned so far. So, pause the video and answer these 3 questions. Which statistic measures variability among individuals, and which measures the precision of the mean? I think you don't need to pause because the answer is already written there. And what happens to SEM when sample size increase? So if you answer the SD SEM and SEM decreases, I think you have got it. And if you understand why I put these examples, I just need you to understand the core idea and the core concept. And here is a very easy memory trick to understand the difference between the standard deviation and the SEM. So the SD stands for the spread of the data, and the SEM means you are sure about the mean. It's not the formal definition, but it's surprisingly effective for remembering the difference. So let's summarize everything. Now, SEM is a measure of precision, not variability. Larger sample size produce smaller SEM values because the estimate becomes more reliable. Never say SEM measures biological variations. That's the job of standard deviation. I hope this explanation made SEM much less intimidating for you guys. And if you enjoy this style of learning, subscribe for more videos where we simply simplify actually the difficult scientific concept into something anyone can understand. So thank you so much again. See you in the next video.